Welcome to this video. In the previous video, we have studied the surface areas of solids made of a combination of basic solids. Today, in this video, we will study the volume of solids made of a combination of basic solids. Can you tell what does volume and capacity mean? Well done! The space enclosed by an object is called the volume of that object. Capacity of an object is the volume of fluid or other object that can be filled in the interior of that object. Can you find out the volume of this pencil? Which method would you use to do this? On looking at this pencil carefully, we observe that this pencil is not a specific shape, but it is formed by a combination of some basic solid shapes. In your previous class, you have studied all these basic solid figures. Can you find out the volume of these solid shapes? Pause the video and write down the volume of these solid figures and then match your answer. Can you see that this pencil is made by the combination of a cone, a cylinder and a hemisphere? Hence, to find the volume of this pencil, we have to add the volumes of these three basic figures. Let these be the measurements of this pencil. Let us now find out the volume of these figures one by one. Can you see that the diameter of this hemisphere is 2 centimeters? Then, what would be its radius? Correct! The radius of this hemisphere would be 1 centimeter. Also, we know that the value of pi is equal to 22 upon 7 or 3.14. On substituting the values of r and pi, and solving, we get volume of hemisphere is equal to 44 upon 21 cubic centimeters. Let's now find out the volume of this cylinder in the same manner. Here, the height of this cylinder is 14 centimeters. So, the value of h is equal to 14 centimeters. Can you tell what will be the radius of this cylinder? Here, you can see that the radius of these figures is same. That is, the radius of cylinder, cone and hemisphere will be equal. And hence, the radius of all of these will be 1 centimeter. Now, for cylinder, on putting the values of pi, r and h and solving, we get 44 cubic centimeters. Similarly, on solving for cone, we get 22 upon 7 cubic centimeters. Now, on adding the volumes of these figures, we can find out the volume of the pencil, which is 49.24 cubic centimeters. Come, let's see one more situation of combination of solids. Suppose we have this piece of wood, from which we have to take out a conical piece of radius 2 centimeters and height 10 centimeters. Can you find out the volume of the remaining piece of wood in the same way? Absolutely correct! We know that this new solid is also formed by a combination of two basic solids, cuboid and cone. But this time, these solids are not joined. So here, we will not find the sum of the volumes of these solids. Since here, one solid is taken out of the other solid, so here we subtract the volume of the smaller solid from the bigger solid. And this gives us the volume of the remaining piece of wood. In this way, today we learned to find the volume of the new solid formed by a combination of two or more solids, and of the solid formed when one solid is taken out of the other. In the next video, we will see some interesting examples based on this. Welcome to this video. Till now, we have learned to find the volume of the new solid formed by the combination of two or more solids, and of the solid formed when one solid is taken out of the other. Today, we will see how we can use this in our daily life. A conical vessel of radius 6 centimeters and height 8 centimeters is completely filled with water. A ball is thrown into the vessel which touches it and some water spills out of the vessel. Find out the volume of the water left in the vessel. Can you tell how we can find out the volume of the water left in the vessel? We know that the volume of the water left in the vessel is equal to the difference of the total volume of water in the vessel and the volume of the water spilled out of the vessel. Also, the total volume of the water in the vessel will be equal to the volume of the conical vessel, that is, the cone. And the volume of the water spilled out of the vessel will be equal to the volume of the ball, that is, the sphere. Because the ball spills out as much water as space it occupies. So we can say that the volume of water left in the vessel is equal to the difference of the volume of the conical vessel and that of the spherical ball. So now, we have to find out the volume of the cone and the sphere. From the figure, the values of the radius and height of the cone are known to us. But the value of the radius of the sphere is not known to us, which we have to find out. Can you tell how we can find out the radius of the sphere? Let the radius of sphere be S. Let's now draw a figure for a given situation, in which we represent the cone by triangle and sphere by circle, where the values of OP and OM are equal since they are the radii of the same circle. Also, AM and AP will be equal. Can you tell why? Since AM and AP are the tangents to a circle from an external point A. You must remember that the tangent to a circle is perpendicular to its radius. Therefore, AP and OP and AM and OM will be mutually perpendicular. Now, by Pythagoras' theorem in triangle APC, we get AC equals to 10 centimeters. Also, From the figure, we can say that Cp is equal to the sum of CO and OP, from which we get CO equals to 8 minus S. In the same manner, from the figure we get MC equals to 4 centimeters. Now, using Pythagoras theorem in right angle triangle CMO, we get S equals to 3 centimeters, which is equal to the radius of the spherical ball. So, let's find the volume of cone and sphere and solve it further. To get the volume of the remaining water, which is equal to 188.57 cubic centimeters. Today, we saw how we can solve the problems related to the combination and separation of solids in our daily life.